Okay, guys, it's 2 days gap. So let me remind you. So what we were discussing. So we were looking at scoop import and export, and we have seen many ways of importing from a RDBMS called MySQL. So we had MySQL in our Cloudera. So we imported the data to HDFS location, and then vice versa, we exported the data to MySQL as well using some commands. So let me recall that. I'll be forwarding these documents once we complete these sessions. So we have uh, we have seen loading the data from a single table we have loaded from RDBMS, and then we have also included a kind of incremental append. So based on last value, so when we are loading the data from MySQL to HDFS, we also have incremental based on the last value. It will scan the table and then fetches only records after 1021 entry. So it's a kind of incremental load. And we have also tried to import all tables to a particular HDFS location. And we have seen, yeah, export. So export from HDFS path to a table, which is available in MySQL. And we have created a job and then we executed the job also. So every time we cannot use that import export command. So we can create the definition of a scoop job. So we can also show our job definition, and to execute job is hyphen hyphen exe scoop job prefixed, and then name of the job we have created, and code gen. Of course, code gen will create for us some jar files based on our input. So what is the input of our statement, whether to import or export, it will generate some jar files. And scoop eval also we have seen. So eval is something that if you want to list out the data or if you want to insert some data.
Raja, sorry for interrupting. So again, we are facing the same issue. Sometimes, like your voice is completely not audible.
Oh,
It's coming
really?
break. Yeah, yeah.
Okay.
It's the same with me. Like,
Yeah, yeah. I think the problem with my PC, I believe. So some sound. I have to change my laptop.
it might be a network issue too, Raja, because these guys use UDP. So maybe,
Zoom.
yeah, because these all guys, like, I don't think they use a TCP thing. So when
All
you
right.
use UDP, network is not proper, some packets get lost.
Okay. Okay. Yeah. Sorry. Yes. Yeah. You can stop me when you are not able to hear me. You can stop me. Yeah. So
Okay.
we have used eval functionality good queries, and you can hit the RDBMS queries, and then you can display the data. You can also insert data. List databases, list tables. So that is used to list out. Then now we have also seen when you are loading the data back to HDFS files, so you can specify what format you want to mention, like all the common uh, syntax that you use to load the data, for example, table, mappers, where, target. But at the end, if you see as packet file, so when you are loading the data, you are hinting the statement that
Sorry, could you please repeat it, Raja? It's not we didn't hear anything
yeah.
actually.
Yes, sure. So what we have seen in this example, so when we are loading the data to HDFS files, we also got an option to specify whether to store as Parquet file, Arrow file. So we can specify that. We have loaded the data using as Parquet file. So if you want to load, we know that Parquet file is like a columnar storage and it will improve the performance. So we can load the data using a specified file format. So this is the syntax that we have seen. Okay. So now what we will see, we have seen only loading the data to HDFS locations, but not to Hive tables. So we will now look at how we can load the data to Hive tables, and then how can we retrieve data from a Hive table to MySQL. But today's discussion, let's see. Let me complete this first, and then Sqoop export we have. Before to that, we will load the data. So this is the syntax. Now I wanted to load the data. So remember one more thing, guys, I forgot to mention. From a table, you can specify a table, and you can also specify list of columns. So to specify list of columns, you have to use hyphen hyphen columns. So when you are using this, only specified columns will be loaded. Okay. And the target directory, even it is not required target directory. So what I'm saying here, Hive import, create Hive table. Okay, and then Hive table kp database dot sqoop import Hive table. This is the directory and name of the database I'm giving to load the data from this user table. I think somewhere I would have mentioned the H catalog, that is here. H catalog. Okay, H catalog. Okay, Sqoop also uses H catalog, but let me first load the data from a table to from a RDBMS table to a Hive table. So for this, you use Hive import extra, and then if there is no table is available, you can also create Hive table. Okay. So now now let me first test whether this table is available or not in my Hive. Earlier we have seen only data exports are imported to HDFS location, but not into Hive table. So we will complete that also. For this, I mentioned Hive import, create Hive table option. So this will create, if the table is not existed, it will create the table. And Hive table, this is the name of the database dot name of the table.
Raja, a small question, Raja.
Yeah.
So creating a table in Hive, we already learned, right? It's normal SQL command. So why in the scoop we are writing in different?
No. This is something different. Our approach is now, see, Sqoop, why we are using importing data from RDBMS to HDFS or Hive. So what I'm saying is, if there is no table in the Hive, I mean, we are not having any table information, but on fly we want to create the table.
So this particular one. So earlier we created the HDFS files, right? We import the we exported the data from RDBMS and we kept it in HDFS, right?
Correct.
The file. So we can now go directly to the Hive and create the tables over there,
Yes,
right?
yes. That is also possible. But this is different. I mean, this is another case where you don't, you don't have any table or any HDFS file. But when you are importing the data from MySQL, you wanted to create the table on fly.
Okay, so it's export, right, or import?
Import. So when you are loading the data from RDBMS to HDFS or Hive, it is import.
Okay.
We are on since we are on Hadoop environment, we say import. And
okay.
So this is just an example, another alternative. Yes, that is correct. When you load the data into HDFS file, you can create external table on top of it, and then you can start querying it. But this is another option that we have. You can load the data into a non-existing table by just giving a hint that you create this table because I don't have.
So is this will create the HDFS file?
We'll see now.
Okay. Okay.
Yeah. So now if you see these KP databases, I just logged into Hive and then I know show tables command, show tables. Yeah, this is the list, but if you see there is no Sqoop import Hive table is available, but the Sqoop import Hive user is not available. This is not available here. Okay. So now it is a button, right? You load the data and then you create the table. So better you can, when you're importing the data itself, you can create the table. So that's what our intention. So let's copy this, create a new terminal. Cloudera is the password. So one more thing, I just used one syntax here. You could observe this, split by user ID. So split by user ID is something that, say for example, you have some 100 users, and when you specify the split by user ID, so it will split into two sets and then perform the import operations. So which will be like a parallel loading. That's what the advantage of this split by. Okay, and columns, I specified only 3 columns to be loaded, not all, from this particular table. And though I have given target directory, since we are creating a new table, it won't work, but I just given a target directory since it was there in other example, it is available, but still it worked. Now we will see whether the import
Raja?
completed or not. Yeah, yes, Charan.
Okay, so columns specified in split by should be in the column names. Like,
No. See, I have 10 columns and I don't want to import all the 10 columns, but I need only 3 columns. In case if you want to
okay, so in columns, it's not like my guess is like when group by use gives
no.
inputs, they
It's
should
not
be.
like that. It's not like that.
Okay, cool.
Say for example, you have 10 columns from your RDBMS, but for your business purpose, for your analysis purpose, those 10 columns are not required. Only 3 are required. So when you are importing, so it's like a space, I mean storage. Why to waste this storage or something like that? Of course we will not bother about storage since we are dealing with big data. But in case if you want to specify only these columns to be loaded, you can specify that. So we have that.
So in the columns section, I can remove the user ID and still use user ID at the split by. Okay.
Yeah.
Thank you. Yeah. Thank you.
Okay. So when you are importing that, if you specify split by, so it will just split the data into 2 parts and then perform the import operations. So the performance will be faster. That's all. So now completed, the data import completed. Now if you see, there was no table here, Hive user table, but now we will see show table. You can see here, Sqoop import. Okay, Sqoop import Hive user. So now let's see create table, show create table statement for this one. Show create table for this particular Hive user table. You see, it is created user ID, gender, age only because we didn't create. The Sqoop import statement itself created this table, and you can see comment also imported by Sqoop on so date. Said it used lazy and then text file input, output also text file, delimited, you see here comma it used, and then line delimited. And if you see this now, location it used, though I have given external location, but it went to kpdatabase.db. So it went to user hive warehouse and then it created as an internal table, guys. Okay, so I really didn't execute this statement, but on behalf of me, when I'm importing the data, so Sqoop itself created because I have given syntax like this: hive import, create hive table, and I have specified hive table, then name of the database followed by the name of the table. Got it?
Yes, Raja.
Yeah. Kalpana, you?
Yes, Raja. But can you show us that HDFS file is created for that?
Yeah. You can see here. You can see inside this location it created here. So now if you really want to see this, you have to go here. End of the day, this is also, even though it is created as a DB, but end of the day, it is also a HDFS location. Go here and then HDFS, DFS.
Okay.
It is not in the external location. It is inside the Hive warehouse. So it is under Hive control.
You didn't mention it, right? Earlier.
Sorry?
But in Sqoop, when you gave that, you didn't mention which location, right?
Yes. You can see here. Where? Here. Okay, sorry. In our statement. KP database. So I given KP database dot Sqoop import Hive user. So it went and created inside KP database dot Hive user, Sqoop import Hive user. So it is an internal table.
Yeah, it's an internal table.
Yeah. Okay. So I'm not sure about external table. Maybe there will be another command to create an, but no need. External table is something that you can give direct HDFS location. So that's not external table, and you can create on top of it. Maybe internal configuration by default is creating internal table, and maybe if you want to create the other one, you can import into HDFS location. You can create a table on top of it, or else you must be having another property to create external table that we will see.
Okay.
And now Sqoop import we will use. So importing the data from a Hive location, not from a HDFS location. So we have seen in the previous example, we loaded the data from a HDFS location to a MySQL database. Okay, now let me use KP. You can see here user export to these two exported from HDFS location. Now we will use export from a Hive table. To do that, same way, Sqoop export, this time Sqoop export, and then connection name, and then user password, then table. This is the table from RDBMS. So MySQL table. So I have given table name, H catalog. You have to specify H catalog because Sqoop won't understand directly. If you give a table name, it won't understand like Hive import. So when you are exporting the data, you can make use of H catalog. So H catalog is something that it is a tool which will maintain meta store of particular Hive. So it built on top of Hive, so it will have all the metadata information of Hive. So PIG or MapReduce program or our Sqoop, so external application can make use of this. So I mentioned just hyphen H catalog hyphen database and name of the database, and then H catalog hyphen table, name of the table. So this particular u underscore user will be loaded into now a table in RDBMS. This is user hyphen Hive export is the table. Now I will specify this as a user. Okay. Yes, we have seen that only these tables are available 1, 2, 3, 6, but we don't have this Hive export user table. Before that, we have to create the table. So unlike we created in Hive, we don't have an option to create this table. So we are creating manually.
Sorry, Raja, could you Raja, could you please repeat that sentence, Raja? Why we are creating the table manually?
No, see, when we are loading the data, so I'm just creating the target table in the MySQL. I don't think we have an option to create that, but let me see whether we have the same option. Just now we created a table by on fly, right? So that option I didn't explore that. So I'm creating external table. Sorry, externally I'm creating a table. Now the intention is to load the data from a hive table to RDBMS table.
Okay.
Okay.
So this is the syntax, same syntax only, but export command we will use. Because there are a lot many options we have to go through Sqoop documentation. So maybe if there is an option to create even the table on fly, we'll have to see. Yeah. For now, I just created a table. And then I'm loading it to this one. So I've listed the tables. There are no tables with that name, hive export user. Sorry, here. It's launching percentage users. So if we're done with this, so we have seen all the possibilities importing, exporting data between HDFS and MySQL. So remember, when you are loading the data from any other RDBMS, you just need to change the JDBC name, which supports to that particular database, and you have to change this JDBC location, and you need to place JDBC drivers inside LIB folder, Sqoop LIB folder. Then only you will be able to communicate with this databases. So JDBC driver, these two are important. Okay, and rest of all will be similar. Only this JDBC connection name only changes, depends on your target RDBMS.
Okay, Rajan.
Yeah, now completed. Now I'll go to MySQL and then list out the tables that I have. You see, export user has come.
Yeah.
That's how you will deal with the data. So we can finish it for this one. We will start HBase, but before to that, we are pending with Apache PIG dealing with semi-structured data. We'll just cover that example and then we'll jump into HBase discussion. So that's all, guys. This is Sqoop. This is it for our session with respect to Sqoop. If you start practicing and if you get any doubts, you can get back to me. Okay, I'll be forwarding this document for your reference. You can refer it. Okay. I'll just close this. I will close all the terminals just to avoid confusion. So, okay, HBase also I launched. I close this. I will launch it later. Hive also I can close this. So now I will launch one terminal and then I will start launching pig in MapReduce mode. So where we stopped in pig, let me recall that also. So we have loaded the data from a file which is from HDFS location. We have seen co-group, we have seen for each group, co-group, join, left outer, and cross between two relations. So we know that we will load the data to a relation. Like this is a syntax. For example, if you want to create a new relation, just give a name and then equal to, and then name of, syntax, whether if you want to join or whatever the activity. So this particular statement will execute, and then the data will be available inside this relation. You can use this relation subsequently to derive new values. So this is what relation, and relation will be available only to that particular session only. Once you exit from this session, so you will see no relation is available. So you have to store it. So to store the relation, we have seen the syntax: store, store particular relation into name of the file. We can give this location, and then using some storage. So this is JSON I'm displaying, but we have seen in the previous class, we have seen storing the data, normal data only. Yeah, this is one. Store A into, this is the one, database. This is a database table. And again, you can see using H catalog. So we also learned how to read the Hive table and then load the data to Hive table. And see here somewhere I have used dump means like to display the data. We have option dump relation name. We splitted the data, we limit the data also. Okay, unfortunately we don't see. Okay, I didn't capture that. So the same syntax only, store relation name into HDFS location, that's all. So now how to process the JSON data. So let me show you this particular file, how the data looks like. Let me launch this HDFS.
So we are seeing semi-structured data.
Correct. So we have seen before using PIG storage, and we have specified the delimiter also, like tab, comma, pipe delimiters, and then we read the data, and then we process the data like this. So PIG storage is something that it's internal storage. You can specify name, and then as after we have specified the what you say schema details, loaded the data, and we played with it like union, group by, everything. So now we'll deal with something JSON. So JSON data comes like this. You can see food, person, amount I have. And if you want to load this particular data, now what we have an option here is like load as usual, load and then name of the file, and using JSON loader. So this time it's not PIG storage. Since we are dealing with JSON data, you have to use JSON loader, and then you have to specify the schema like this. Within single quotes, you have to specify food, char array, person, char array, amount, int. So let me run this. So the relation created JSON data. We know how to display the data. JSON dump. So it is also, we know that it is a MapReduce concept end of the day. So it created a jar file and then followed with the mapper launch, reducer launch. So number of splits here 1, which means that it is processing entire set. It is not processing into multiple splits. And a job is created on a job tracker. So we can see the status here. Every job will have its own unique ID. Yeah, now you see dump. When I dump this, you see the data is okay. It is in another 10 minutes. It will stop. Okay. So now you see here the data displayed like this, though we read the data from a JSON file. So you can again store it back to a HDFS location, that is different case. Now we will see nested format. So nested format, in case of nested format, how you have to give same syntax, but only thing is, yeah, let me display the data first.
So nested formats should give bags, right? If I'm correct.
Inside
PIG, inside PIG, you should get bags, right?
Yes.
Okay.
Now you see here inside this particular recipe and then ingredients, again you have one more kind of you can say combination, like tuple combination. It is started the square bracket and ended here, and this is one more column. So inventory is one more column and then recipe is one more column. So inside recipe again, ingredients, you have one more combination. So the similarly second row. So now to do, if you want to deal with this kind of data, so you see here syntax, you have to specify name of the column char array, and then you can see here ingredients, and then one more bag you need to open and then specify name char array, and then comma inventory something that the other one name and char array age. If you go back and see here, yeah, inventory something that a new column. Inside this again you have one more, so you have to open the bracket again here, specify this is a different column, this is recipe is different column. Inside recipe you are having one more sub attribute. For that I'm specifying one bag, so it stopped, I mean it's ended here, it started here and then ended here. This is a new column. Again inside this you have two attributes. Now you see the data.
Oh, sorry.
Yeah, no problem. Let me copy this also.
For integrants, you didn't mention the type, whether it is a char array or something. You just mentioned the inside attribute char array.
Now you see here, so recipe is something that char array, this is the one, okay, and ingredients is the name of the super attribute and it contains this, right? So now I define ingredients colon, then inside a bag I have defined name as a char array. So now if you see inside ingredients we have a just name column, so 1 2 3. Now this one is again a new attribute like ingredients. So name I've inventor I've given, and then again name and age I have. So here you have only one attribute name, but here then the second attribute we have a name and age. So I have given inventor. The same syntax. You see these two are same. Since you see that this particular ingredients is having only one column name. So I have defined like this ingredients colon bag within this name and then char array. So similarly, I'm giving inventor also, but I have multiple columns. So I just specify like this bracket name char array comma age int.
Okay, Raja.
So now let me load this. Somewhere. The tuple has been created here. Inside tuple, we have a bag till here, and then again one more tuple. Okay, let me copy this and then place it inside the file. We'll start analyzing. Yeah, you can see here. So recipe, this is the one, and ingredients, if you see, this bag has been created, and then finally we are specifying tuple. Even you can ask me, like, you can create a bag here also, like you can specify like this, and you can give the same as ingredients how you have a bag. You can also create a bag, but I just want to display bag and tuple combination inside a tuple. So that's why for ingredients I've given a bag, and this one I maintain it as a tuple.
Okay, Raja. Yeah.
Okay. Charan, you asking something?
No, I said, yeah, I understood that. Like,
Kalpana, how about you?
Got it, Raja.
Yeah. So just how we have the data in our file, we just given the schema in such a way to access it. That's all. So now one more thing is we can also load the data. I mean, like a text file format data to a JSON data format. So for that, you have to give JSON storage. So when you're storing the data into a HDFS location and you wanted to store it as a JSON format, so you have to specify here. When you're loading the data, you used JSON loader. When you are storing the data, you have to using JSON storage. So let me load this particular table, user data, using pipe delimiter. Okay, yeah, I've created user data. Now if you want to store this particular user into, I'll specify dump u underscore user JSON. So it will create a file along with schema also inside this particular location. Let me see whether I don't think so. I can give JSON. I'll just give just name of the folder. That's all. Let's see. I'm not giving any file extension. Let's see how it will.
Raja, a small reminder, like you
Yes.
said, it's 10 minutes or something with the recording.
Yeah, 1 minute. I think it will complete, Raja. Sorry, Charan.
Oh, okay. I just wanted to remind you to see
No
that
problem.
thing so
Yeah,
we don't lose anything.
yeah. We will just display this file and then close. So it will be a continuation. So meanwhile, I'll just clear this and then go for it, and then display the content inside this HDFS location. I have given till here only. Yeah, it's completed. Now let's go and if it disconnects, we will join back. Now you see here part M0 created along with pig schema. So let me cat it. Part -m